Have scientists finally cracked the code of the Great Pyramid? For 4,500 years, its secrets have been locked inside millions of tons of stone. But now, groundbreaking discoveries are peeling back the layers of mystery, revealing a level of ancient technology that defies everything we thought we knew. The Great Pyramid of Giza is not just a tomb. It is a declaration of human will, a masterpiece of engineering that has humbled generations of architects and engineers. For millennia, the question has not been who built it, but how. How did a civilization, armed with what we've long considered rudimentary tools of copper and stone, quarry, transport, and perfectly align over 2.3 million blocks of limestone and granite, some weighing as much as 80 tons? The sheer scale is staggering. The base of the pyramid covers 13 acres, an area that could comfortably house 10 football fields. And for over 3,800 years, it was the tallest man-made structure on Earth. Its sides are aligned to the cardinal points with an accuracy that modern builders would struggle to replicate, off by a mere fraction of a degree. This isn't just impressive for its time, it's a miracle of precision. The most conventional theory, the one taught in schools and displayed in museums, involves a system of ramps. Yet the ramp theory is riddled with problems. To reach the pyramid's final height of 481 feet, a single straight ramp would have needed to be over a mile long, requiring more material and manpower than the pyramid itself. The logistics are a nightmare. A spiraling ramp wrapping around the pyramid as it was built presents its own set of challenges. Such a ramp would have obscured the very lines of sight necessary for the builders to maintain the structure's perfect geometric shape and precise angles. Every corner, every angle had to be surveyed continuously, a task made impossible if the pyramid's faces were perpetually covered by a massive construction ramp. This has led to more innovative and some might say radical theories. French architect Jean-Pierre Houdin proposed a fascinating alternative: an internal ramp. Houdin, who dedicated years of his life to creating a 3D digital model of the pyramid, suggested that while an external ramp was used to build the lower third of the structure, the rest was constructed from within. He theorized that a spiraling internal tunnel, which may still exist within the pyramid's walls, allowed workers to haul the blocks upward from the inside out. This theory elegantly solves the problem of surveying the exterior angles and explains certain anomalies, such as a notch discovered on one of the pyramid's edges that could have been a corner point where blocks were pivoted. In 2000, a survey using microgravimetry detected a spiral-shaped void within the pyramid, lending tantalizing, though not definitive, support to Houdin's hypothesis. But what if the solution was simpler, yet more ingenious? What if the ancient Egyptians harnessed the power of water? The idea of using water to move the massive stones has gained traction in recent years. The discovery of a papyrus journal belonging to an official named Mirror, a foreman who worked on the pyramid's construction, provided the first ever first-hand account of the process. Mirror's diary describes how his crew transported limestone blocks from the Tura quarries to Giza via a system of man-made canals branching off the Nile. Archaeologists have since uncovered evidence of a lost port near the Giza plateau, suggesting that boats could deliver materials right to the base of the pyramids. This water shaft theory takes it a step further. Proponents suggest that a series of locks and water-filled shafts could have been used to lift the blocks internally. By pumping water into sealed chambers, the blocks could have been floated upwards level by level. While there is no direct archaeological evidence for such a system within the Great Pyramid itself, the concept is not without precedent in ancient engineering. The Egyptians were masters of irrigation and understood hydraulics. Could they have engineered a colossal hydraulic lift inside the pyramid? The idea is speculative, but it addresses the primary challenge: lifting immense weight with minimal friction and effort. It would have been a technological solution of breathtaking genius, hiding its own mechanism within the very structure it was building. Then there are the tool marks, or rather, the lack thereof. The precision-cut granite blocks inside the king's chamber, for example, show evidence of a cutting technology that seems far beyond the capabilities of simple copper saws and stone pounders. The surfaces are perfectly flat, the corners razor-sharp. Some researchers, like engineer Chris Dunn, have pointed to evidence of what appears to be high-speed drilling and machining. Dunn argues that the core holes drilled into some of the granite artifacts show feed rates that would challenge even modern diamond-tipped drills. This has led to speculation about lost ancient technologies, from advanced sonic drills that used vibration to cut stone, to some form of geothermal energy harnessed to power their tools. While mainstream Egyptology dismisses these ideas as pseudoscience, the physical evidence on the stones them. For centuries, the Great Pyramid was defined by a single word: tomb. It was built, according to mainstream history, as the final resting place for the 4th dynasty, pharaoh Khufu. The internal structure seems to support this. A subterranean chamber, the so-called Queen's Chamber, and the King's Chamber, which houses a large granite sarcophagus. The entire Giza Plateau is a necropolis, a city of the dead filled with smaller pyramids, mastabas, and temples dedicated to the afterlife. The pyramid's alignment, its intricate passages, all seem to point towards a sophisticated funerary purpose, a machine for launching the pharaoh's soul into the stars. The sarcophagus in the King's Chamber, however, is empty. It's also slightly too large to have been brought in through the ascending passage, meaning it must have been placed inside as the chamber was being built. There are no inscriptions within the King's Chamber, no hieroglyphs detailing Khufu's life or his journey to the afterlife, a stark contrast to the lavishly decorated tombs found in the Valley of the Kings. This has led some to question whether Khufu was ever interred here at all. Was the pyramid a decoy, or was its purpose something else entirely? One of the most enduring alternative theories is that the Great Pyramid was a sophisticated astronomical observatory. The precision of its alignment to the cardinal points is just the beginning. The descending passage, for instance, is thought to have been aligned with the pole star of the era, Thuban. An observer looking up from the bottom of this long, narrow shaft would have had a perfect, unobstructed view of the star, allowing for incredibly precise measurements of the sky. Robert Bauval's Orion correlation theory proposed an even grander celestial plan. Bauval suggested that the layout of the 3 Giza pyramids, Khufu, Khafra, and Menkore, was a deliberate terrestrial map of the 3 stars in Orion's belt. The alignment isn't perfect, but it's close enough to be provocative. Bauval argues that the Giza complex was designed to be a mirror of the heavens, a sacred landscape that connected the pharaohs with the gods and the stars. The so-called air shafts extending from the king's and queen's chambers, which were once thought to be for ventilation, also point towards specific stars. The southern shaft of the king's chamber aimed directly at Orion's belt, while the northern shaft targeted the circumpolar stars, the imperishable ones that never set, a destination for the pharaoh's eternal soul. This idea of the pyramid as a functional device, not just a passive monument, has led to even more exotic theories. The notion of the Great Pyramid as a giant power plant has captivated inventors and mystics for over a century. Proponents of this theory point to the pyramid's unique materials and construction. The outer casing was made of highly polished Tura limestone, an excellent insulator. The inner passages and chambers are primarily built from granite, a stone rich in quartz crystals, which has piezoelectric properties, meaning it generates an electric field when put under pressure. The theory posits that the pyramid was designed to harness the Earth's natural vibrations and convert them into energy. The subterranean chamber, located deep in the bedrock, could have been connected to an underground water source. The flow of water would create vibrations, which would then be amplified by the pyramid's resonant structure, causing the quartz and the granite to release electromagnetic energy. The air shafts might not have been for air or souls, but for waveguides, directing this energy towards a specific target. While there is no concrete evidence to support this, and the physics are highly speculative, the idea persists because it attempts to explain the pyramid's many anomalous features through a single unified theory. It transforms the pyramid from a dead monument into a living machine. The truth may be a synthesis of all these ideas. The pyramid could have been a tomb, an observatory, and a symbolic representation of the Egyptian cosmos. Its purpose may have been multifaceted, designed to function on multiple levels. As a physical tomb for the pharaoh's body, a spiritual engine for his soul's journey, and a monumental testament to the knowledge and power of the civilization that built it. The lack of inscriptions might be a feature, not a bug. A silent monument whose meaning was conveyed not through words but through its perfect geometry and celestial alignments. It was a structure designed to be read by the stars themselves. For centuries, we believed we knew the layout of the Great Pyramid. The 3 known chambers and the Grand Gallery were thought to be the extent of its internal structure. But in the 21st century, a new era of exploration began, one that uses cutting-edge physics to peer through the stone without moving a single block. In 2017, the Scan Pyramids project, a collaboration of international scientists, announced a discovery that stunned the world. A massive, previously unknown void located directly above the Grand Gallery. Using a technique called muography, which detects particles called muons that rain down from the atmosphere, the team was able to create a 3D image of the pyramid's interior. Muons lose energy and are absorbed as they pass through stone, but they pass unimpeded through empty space. By placing detectors inside and around the pyramid, the scientists could map out areas of lower density. The results revealed a void at least 100 feet long, with a cross-section similar to the Grand Gallery below it. They named it the Scan Pyramid's Big Void. The discovery was monumental. It was the first major new structural discovery inside the pyramid since the 19th century. But what is it? Theories abound. Is it a hidden chamber, a repository of treasures or sacred texts that has lain undisturbed for 4,500 years? Or is its purpose purely structural? Some Egyptologists believe the void may be a construction gap, a space left intentionally by the builders to relieve pressure on the ceiling of the Grand Gallery. The immense weight of the masonry above could have collapsed the gallery's corbelled roof, and this void would have acted as a stress-relieving chamber, a brilliant hidden engineering solution. This wasn't the only discovery. The same project also identified a smaller void, a corridor-like anomaly located behind the north face of the pyramid, near the chevron blocks that sit above the original entrance. In 2023, a team was able to insert a tiny endoscopic camera through a joint in the chevron blocks, confirming the existence of a corridor about 30 feet long with a vaulted ceiling. It leads nowhere, ending in a solid limestone wall. Its purpose remains a complete mystery. Was it another construction feature? Or was it an unfinished passage, a clue to a different, abandoned architectural plan? These discoveries have reinvigorated the search for hidden chambers. The idea that the pyramid still holds secrets is no longer the realm of fiction. The voids prove that our understanding of the pyramid's internal structure is incomplete. They open the tantalizing possibility that the true burial chamber of Khufu has yet to be found. The king's chamber and its empty sarcophagus could be an elaborate decoy designed to mislead tomb robbers, while the pharaoh's real tomb, filled with his funerary goods, lies hidden somewhere within the pyramid's massive bulk. The search is now focused on these new voids. Scientists are developing more advanced imaging techniques and miniature robotic explorers that could one day navigate these hidden spaces. The challenge is immense: to explore these areas without causing any damage to the ancient structure. Every step is taken with extreme caution, but the potential reward is immeasurable. Finding an intact burial chamber, or even a sealed-off corridor containing artifacts, would be the archaeological discovery of a lifetime. It would rewrite the history books and give us an unprecedented glimpse into the world of the Old Kingdom pharaohs. The voids are a silent testament to the fact that the Great Pyramid has not yet yielded all its secrets. It is still, in a very real sense, a live archaeological site, with the most exciting discoveries perhaps yet to come. The Great Pyramid does not just cast a physical shadow across the Giza Plateau. It casts a conceptual one across human history. Its existence challenges our linear view of the past, the neat progression from primitive to advanced. The pyramid suggests a high-water mark of knowledge in the ancient world, a peak of technical and scientific ability that was perhaps lost or forgotten for millennia. This idea is at the heart of what is sometimes called the pyramid's shadow, the notion that the structure itself is a repository of lost knowledge, an encyclopedia written in the language of mathematics and stone. Consider the pyramid's dimensions. The ratio of its perimeter to its original height is remarkably close to 2 pi, a relationship that shouldn't have been accurately calculated until the Greeks thousands of years later. If you take the height of the pyramid and multiply it by 43,200, you get a number very close to the polar radius of the Earth. If you take the perimeter of the base and multiply it by the same number, you get a figure approximating the Earth's equatorial circumference. The number 43,200 is significant in itself. It's derived from the precession of the equinoxes, the slow wobble of the Earth's axis, a cycle that takes approximately 25,920 years to complete. The Egyptians were known to be keen astronomers. Is it possible they had calculated these values with such incredible accuracy? Skeptics argue these are mere coincidences, the inevitable result of numerology and cherry-picking data. But the coincidences keep piling up. The pyramid's location is also intriguing. It sits at the center of the Earth's landmass. Lines drawn from the pyramid to the northeast, northwest, southeast, and southwest encapsulate the Nile Delta with perfect symmetry. It is a point of immense geographical and geopolitical significance, i.e., this has led to the theory that the pyramid was not just a monument, but a geodetic marker, a key part of a global system of measurement. The unit of measurement used in its construction, the royal cubit, may have been derived from the dimensions of the Earth itself. This implies a level of scientific knowledge in geography, mathematics, and astronomy that is completely at odds with the conventional picture of the Bronze Age. The potential for water sources within the pyramid adds another layer to this shadow of knowledge. The presence of salt incrustations on the walls of the Queen's chamber has led some researchers to suggest that the chamber was once flooded. The so-called air shafts in the Queen's chamber were sealed at both ends, and when a small robot drilled through one of the stone doors blocking the southern shaft in 2002, it found another door just behind it. What if these shafts weren't for air but for liquids? Some have theorized that a chemical reaction involving the mixing of two different solutions brought in through these shafts could have generated hydrogen gas. The pyramid, in this view, becomes a massive chemical apparatus. This is, of course, highly speculative, but it speaks to the pyramid's power to inspire theories that push the boundaries of our imagination. It forces us to ask, what did the ancient Egyptians really know? Was their science based on a different paradigm, one that we don't yet understand? The pyramid's shadow is the shadow of our own ignorance. It represents the vastness of what we don't know about our own past. It stands as a silent rebuke to our modern arrogance, a reminder that primitive does not mean simple. The builders of the Great Pyramid possessed a deep, sophisticated, and perhaps holistic understanding of the world. One that integrated science, religion, and art in a way that we have long since lost. The structure they left behind is a challenge to rediscover that lost knowledge, to understand the world not just in pieces, but as an integrated whole, just as they did. The age of swashbuckling archaeologists dynamiting their way into tombs is long over. The future of pyramid exploration is one of caution, respect, and technology. The primary directive is to preserve this priceless heritage for future generations. This means that any new exploration must be non-invasive, using technology that can see without touching, and explore without destroying. The success of the Scan Pyramids project has opened the door to a new era of discovery. Muography, ground-penetrating radar, thermal imaging, and other remote sensing technologies will continue to be refined and applied to the pyramid. The goal is to create a complete, high-resolution 3D map of the pyramid's interior, revealing every hidden void, every sealed passage, every subtle change in density. This will allow archaeologists to excavate the pyramid digitally, exploring its secrets without ever lifting a chisel. Where physical exploration is necessary, it will be done on a miniature scale. The next generation of robotic explorers will be smaller, more agile, and more intelligent. They will be able to crawl through tiny cracks, navigate complex passages, and send back high-definition images and data. They may be equipped with miniature drills to take microscopic samples of mortar or stone, or with sensors that can analyze the chemical composition of the air in a sealed chamber. The goal is to gather as much information as possible with the smallest possible footprint. The future of exploration is also collaborative. It will require the expertise of not just Egyptologists and archaeologists, but also physicists, engineers, data scientists, and robotics experts. International teams, like the one behind Scan Pyramids, will bring together the best minds from around the world to tackle this shared challenge. The data they gather will be open source, allowing researchers everywhere to contribute to the analysis and interpretation. But the ultimate goal is not just to find hidden treasures or solve ancient riddles, it is to understand. To understand the people who built this incredible monument, their beliefs, their society, their science. The Great Pyramid is a time capsule, a message in a bottle from a distant past. It is a puzzle that has been waiting 4,500 years to be solved. And with each new discovery, with each new technological advance, we get one step closer to reading that message. The fascination with the Great Pyramid will never fade. It is a symbol of the enduring power of human curiosity. It reminds us that there are still great mysteries left in the world, secrets waiting to be uncovered. And as we continue to peel back the layers of this ancient enigma, we may find that the most profound discovery is not a hidden chamber or a golden treasure, but a deeper understanding of our own potential, our own history, and our own place in the universe. The future of the pyramid is not just about looking back into the past. It's about looking forward to the incredible discoveries that still lie ahead.